In this video, we're going to look at the famous chain rule, which is a rule that will help us find derivatives of functions that we recognize as composites of other functions. So, here's the rule. Suppose we want to find the derivative of f of g of x. Well, the chain rule says that this is f prime of g of x times g prime of x. Here's another way to say that. If we recognize g of x as the inner function, so the function which takes the input first, and f as the outer, then this expression on the right is the derivative of the outer evaluated at the inner, then times the derivative of the inner. Let's look at an example. Suppose our function is sine of x cubed. So what are our inner and outer functions? I think for sure the inner is x cubed and the outer is sine. So what are their derivatives? The derivative of sine is cosine, and the derivative of our inner function x cubed is 3x squared. So if we put that together, it should be the derivative of the outer, but evaluated at the inner. All right, so x cubed is plugged into cosine, but then don't forget to multiply by the derivative of the inner. Let's look at another example. F of x is the quantity x squared plus x all to the 10th. Now note that f is playing the role of the overall function here. In the previous example, it was one of the functions that was being composed, but here it's the overall function. So let's pick out our inner and outer function. So I think the inner is x squared plus x. That's what you would do first. Take the input, square it, and add it to itself. Then the outer is raising to the 10th power. Okay, so we've identified our inner and outer functions. Their derivatives are pretty easy in this case. 10x to the 9th for the outer and 2x plus 1 for the inner. So to find the derivative of our function f, we should take the derivative of the outer, but plug in the inner, and don't forget to multiply by the derivative of the inner. Okay, let's look at one more. Our function is cosine of natural log of x squared. So yes, for sure the outer is cosine. And the inner now is natural log of x squared. So remember, we've got to find their derivatives. So the derivative of the outer we know is minus sine of x. But what about the derivative of natural log of x squared? Well, that is actually itself a chain rule. So in finding the derivative of our inner, we're going to have to perform another separate chain rule. So let's do that. So let's work that completely inside the box. Let's pretend that's our whole problem right now, is finding the derivative of ln of x squared. So I'll call that g of x. So right now inside the box we're only considering the derivative of this function. So now we've got to find its inner and outer functions. So I think the outer is natural log and the inner is x squared. And we know the derivative of ln of x is 1 over x. The derivative of x squared is 2x. So how about the derivative of g? The derivative of the outer, but plug in the inner, times the derivative of the inner. And in particular, that gives us 2 over x. So that should go up here. The derivative of ln of x squared is 2 over x. So back to our original problem here, f of x. Now that we have our outer, inner, and their derivatives, you ready? The derivative of the outer, but evaluated at the inner. So I'm plugging ln of x squared into minus sine. But don't forget to multiply by the derivative of the inner.